Exercise 1.2, the first question. State whether the following statements are true or false and justify your answer. Okay, very simple exercise it is. First one is, every irrational number is a real number. See children, we know real numbers. Okay, real numbers means what? They are nothing but they consist both rational and irrational. So rational and irrational number together make real numbers. Very simple concept. So in simple way I'll explain here. Rational plus irrational, okay, together make real numbers. That means this set of, okay, the real numbers are rational and also they are irrational. So this is the concept. And every irrational number is a real number. Very true it is. Yes. Why? The reason is that we know that real number consist both rational, this way, right, rational and irrational numbers. Only this much. Okay, very simple concept. Now moving to the second one. This is very interesting. Every point on the number line is of the form of root m, okay, where m is a rational number. They are saying here where m is a rational number. Okay, rational number means here, you know, it is, okay, before moving to that one, so simple concept, it is 0, we have 1, 2, these are positive numbers, and here we have -1, -2 and -3. As we know, rational numbers, they are positive and also negative, we get rational numbers, is it? So where m is a rational number means, of course, if it is root 2, then you are going to call it as what? It is a point on the number line. We can represent it on number line, and if it is root 3, even we can locate it. And it is a what? Point on the number line. What about the number if it is -2, minus square root of -2 and square root of minus root 3? So these are called imaginary numbers which cannot be represented on the number line. We won't get square root of negative numbers on number line. Because of that one, this statement becomes what? This is wrong, because m is a rational number. Rational numbers may be negative and positive. In the case of positive it's true, but in the case of negative it is wrong, so not possible. So you are going to call it as what? False. Yes. Then moving to the third one. Every real number is an irrational number. Once again it is also false. Why? We know in the first one only, as I discussed, every real number is irrational. They are saying, see children, every real number is what? Of course, real numbers are irrational and rational, but all the numbers are not irrational. They are what? Some numbers are rational and some numbers are irrational. They are saying here every number is irrational, which is wrong. See, for example, suppose if we have 1, so square root of 1, it is what? Rational and also irrational. You are not going to call it as an irrational number, because square root of 1 is 1, which is a rational number. So, okay, you have 2 is a rational number, and square root of 2, of course, it is irrational number. Not all the numbers are irrational. Okay, so every number, real number, is an irrational. This statement is wrong. As you are going to say here, you just write a line that as we know, real numbers may be rational and irrational. Because of this, see, this is exercise 1.2. Now I am discussing the second question. Just we have simple concept, and here you have to understand the concept. Okay, and solution is very simple, and there is no much solution and calculation, all that one. Understand the statement well, because it will help you in understanding the numbers, and where most of students they get confusion with rational and irrational numbers. Okay, now one more interesting here, what the question it is asked: are the square roots of all positive integers irrational? So very interesting. What the question is, are the square roots of all positive integers irrational? Positive integers means 1, 2, 3, 4, so on, is it? Maybe fraction also, 1/2, okay, 1/3. Okay, positive integers. Integers means both we get positive and negative, and they are mentioning here positive integers. So in that case, whether they are irrational, you are asking. Okay, if they are irrational, then you say it is true. But here, square root of 1 is 1, which is a rational. Okay, square root of 2, it is irrational. Am I right? Square root of 3, it is irrational. Square root of 4, which is 2, it is a rational. Is it? See here, I have seen most of the students often Many students make mistake with whenever you find a root of a number, you are immediately going to write this one as what? Irrational number. It is not like that, children. Square root of, if it is not a perfect square, only in that case you are going to call them as irrational numbers. Square root of 4, square root of 9, so square root of 25, these are not irrational numbers. These are rational numbers. As you know, this is 2, this is 3 and this is 5. So you are not going to call square root of all the numbers as what? Irrational. So here, if not it is asked, give an example of the square root. Give example of root 4. You say here square root of 4, it is a positive integer, and square root of 4, we know that it is 2, which is a rational number. This way you have to explain. This question, exercise 1.2, question number 3 of that one. Show how root 5 can be represented on the number line. This is important from the point of exam also. See here, this is very simple. How to draw this one without any confusion. I'll just show roughly, and afterwards I'll show you neatly how to draw this one with accurate measures. Okay, now show how root 5 is it. Root 5, see children, root 5, it lies between what perfect square numbers? Root 4 and root 9. Am I right? Square root of 4 is 2 and square root of 9 is 3. That means root 5 comes between 2 and 3. This is the point. Okay, then it is greater than 2 but smaller than 3. This is the point. How to see? So you may get root 2 for exam, you may get root 7 for exam. In all the cases, how to solve? It is not only root 5. See here. Now first, when you draw a number line, so 0, 1, 2, roughly I'm showing, I'll show you afterwards. It is between 2 and 3. Then you are going to mark on 2 the perpendicular line, and from there you are going to do the construction. See here how to do this one, and why I selected 2, that I showed, not on 3, but it is between 2 and 3 means somewhere here it is. Okay, now how to draw that one? See here, already I have drawn this number line. Very simple. You take 1 unit of distance. At 1 unit distance, the numbers like 0, so number line must consist 0 and the negative numbers. Then look at this one, 0, 1, 2, 3, 4, 5, 6. You can write this way. Then on, as I told you, on 2 I am going to draw perpendicular line. Just roughly you can draw a perpendicular line like this one. So draw it straight. Okay, then take 1 unit. 1 unit means don't take this one 0 to 2 here. This is the mistake what most students they make this one. 1 unit means 0 to 1. This unit what you have taken now. So 1 unit you make it and mark that same unit here. Yes, from this one point. So I call it as A for example. Then you call it as B. AB is what? 1 unit. Yes. Then you join this one. Okay, this is the construction. This is the, okay, but this is not a root 5. You are going to draw this way. This one you are joining. Then okay, I'll call it as O, OB. Now OBs are not the, of course it is root 5, but you have to show this root 5 on number line. For that one, what you are doing, you are just making a curve like this one. You are completing this one here, and here this one, what is our, this one after 2, what you have got now, that is our root 5. Call it C. Then you are going to say OC is equal to root 5. Okay, how you will get that one? I'll show you how it is root 5. Exactly, I'll show you. You know that one. Okay, we have a triangle like this one. Am I right? Here you have this one O, and then calling as A, and this one as B. So if you get this one as root 5, it's correct, our calculation. Is it? And 0 to, that is O to A, it is how much it is? 2 we have taken, and from here it is 1 unit. Is it? So according to our Pythagoras theorem, it becomes a right angle triangle. OB square is equal to, very simple, OA square plus AB square. Check it this way. Then OB square, what we are going to measure? OA square is 2 square plus AB square is 1 square. Is it? 2 square is 4 plus 1 square is 1. So 4 plus 1 is 5. What is 5? OB square is equal to 5. Then OB is equal to square root of 5. That is what? So this distance is root 5. The same distance when you mark here, this one is what? Root 5 on the number line. So this way you are going to locate root 5 on number line with the help of what? Right angle triangle. That is our Pythagoras concept, theorem concept we are using, and you are drawing root 5 on the number line this way. So here you are, see, once again I want to say here 2 you are taking, and most of the students from here they take 2 units, which you are not going to get the correct measure, and somewhere else it will you will mark that one. So root 5 is between 2 and 3, and you have to remember this one. You have to keep you have to take 1 unit from 2. 1 unit means 0 to 1, this distance you are taking. Then you are marking one mark here, an arc. Then you are joining this one. Once again I am repeating, on 2 you are drawing a perpendicular. Then 1 unit you are marking on that perpendicular line. Then you are joining OB. Then what you are doing here, you are taking the help of the compass and you are taking this one as a radius. Okay, and you are completing an arc, something like the circle, something like a semicircle, something like this one. And the point where it touches the number line, that point is nothing but root 5 on the number line. This way, children, you are going to locate root 5 on the number line.